Hello everyone. Welcome to AI-powered early attendance capturing system using Amazon Web Services. This is the system which automatically captures the image of the classroom for every 1 hour and checks for the students who are present and updates their attendance in the DynamoDB. This is the architecture of our project. Here the camera device will capture the image of the classroom. The Python program will upload the captured images to the AWS S3 bucket, and the same captured images are given to the model in the AWS recognition service, which will return the roll number of the recognized students. The roll number is given to the API, which will update the corresponding student's attendance in the DynamoDB using an Lambda function. Our serverless web application will call an API which will get the updated attendance from the DynamoDB using a Lambda function and then display the student's attendance on our web page. Now let's start with the Amazon recognition service. In the custom labels, I have created a dataset called train with images of 4 persons which has 30 images of each person. For this demo, I am using images of some famous persons and labeled all the images with some roll number, such as 1 for Narendra Modi, 2 for Donald Trump, 3 for Elon Musk, and 4 for myself. Using this dataset, we'll train a model. This is the model which I have trained. This is the ARN of the model which we'll be using in our Python code. To start our model, we need to run this command on our command prompt. We need to remove these slashes. Now it's starting. Now you can see that the status of the model is starting. Until it's ready, we'll have a look on our Python code. This is the Python program which will carry out the major part. We need to import Boto3 to interact with AWS services, request for API call, date time to get the present date and time to run the Python program after a period of time, and CV2 for capturing the images. These are the credentials. The whole program is inside this for loop because if there are 6 classes per day, then we need to capture one image per class. And to make the program wait for 1 hour, we are using this time.sleep of 3600 seconds, that is 1 hour. This is used to get the current date and time. This will read the live camera feed. This will capture the image with the current date and time and store it in a folder called early class images. And finally, stop the camera. This will upload the captured image to the S3 bucket called Smart Attendance. This is the ARN of our model. This is used to pass the captured image to our recognition model. In response from the recognition model, we'll get the roll number of the recognized students. If the students are not recognized, then we'll print as not identified. The roll number of the recognized student will be passed to this API. This is the API which will take the roll number from our Python program and pass it to the Lambda function. This is the Lambda function which will take the roll number and update the attendance of the corresponding student in the DynamoDB. This is the students attendance database, where you can see the attendance of the respective students. To view the attendance details, I have created a simple web application using HTML and JavaScript. This is the HTML code to display the table, and this JavaScript will call an API which will get the attendance details from the DynamoDB. This is the API which is called by our JavaScript, which in turn calls this Lambda function. This Lambda function will get all the details from the DynamoDB and return it to the API. Once the API is called, the returned student attendance details will be stored in the response, and then the response is stored in the JSON format into the data, and then the data is organized into a table format. Now let's see our web application. This is the student attendance details. We can see that the attendance is 8546. Now our recognition model is ready to use. Let's move to Python program. Due to low quality of my camera, our recognition model will not be able to recognize the faces in the image. So for the demonstration, I will be using an image captured from my phone. I have stored this image into this folder. Now let's run this program. The image is captured with the current date and time. You can see the same image here, and the same image will be uploaded to the S3 bucket. This is the smart attendance bucket, which will have the same image. We can see that our model is able to recognize the face in the image as it has responded the roll number as 3 because Elon Musk was labeled as roll number 3. The program will capture the image for every 1 hour. So let's stop the program and check the attendance on the web page. We can see that attendance of roll number 3 has been updated, which was previously 4. Now let's update the attendance of another person, say Donald Trump. We'll pass the image of Donald Trump. Now let's run our program. This is the current date and time. It has captured the image and stored it into the S3 bucket. Here also our model is able to recognize as Donald Trump was roll number 2. Now let's check the attendance of roll number 2. I'll refresh this. Now we can see that the attendance has updated to 6, which was 5 previously. Further, this web page can be added with real-time application. In this way, the attendance can be taken automatically without any manual interaction. For more information, check out the link in the description below. Thank you for watching.